Assalamualaikum and good day. My name is Maslina Binti Abdullah, and today I am presenting my final year project 2, which is modeling of residual soil mixed with bentonite as a soil liner. Rapid urbanization causes drastic impact of waste contamination. One of the most common mitigation process is compacted clay liner or CCL. This is due to the slow interception of liquid, high durability, excellent performance of permeability, and low cost. Besides, we also need to utilize our local soil. In Malaysia, the common soil are residual soil due to the hot and humid tropic country. Yet, most of residual soil does not complement with linear requirement. Hence, suitable blended material are needed like bentonite to be used. This is because bentonite has a high smectite clay which provide the swelling potential when in contact with water. There are two problem statements in this study, which is time cost effective. In time cost effective, compacted clay liner is cheaper than incineration. Natural materials should be utilized entirely because imported materials are expensive. Next is the unavailability of blended material. The unavailability of blended material of suitable soil and material require alternative replacement. It is vital to choose appropriate material during the designing stage to reduce the negative impact. As for the objective, there are three objectives, which is to collect the data of physical and geotechnical properties of soil from previous compaction data, to develop empirical predictive models based on regression equation for compaction properties, and lastly is to validate whether residual soil blended with bentonite is suitable as soil liner through mathematical equation. In this study, I am focusing on the mathematical modeling on compaction properties of residual soil with bentonite using Minitab. There are several types of residual soil that are being used, which is metamorphic, sedimentary, tropical, igneous, and laterite. Meanwhile, the bentonite percentage used is 5, 10, and 15%. The significance of this study is to obtain the correlation of residual soil with bentonite. This is because different engineering properties provide different relationship between parameters. Next is to reduce and estimate amount of clay to be used and to minimize the leakage of leachate of soil. As for the literature review, there are 4 major elements in this study, which are residual soil, bentonite, soil liner, and compaction. From previous study, increase in moisture will result in lower dry density. The addition of bentonite enhances the compaction performance. This is because high bentonite content will increase the moisture. For the regression analysis, the correlation denoted as R is to measure the strength within variables. The value of R should lie within 1, whereby the sign indicates the shape of the graph. For example, the researcher wants to know whether plastic limit or liquid limit affect maximum dry density the most. From the result, we can conclude that liquid limit influence maximum dry density better because the strength value is nearest to 1. There are several methods to conduct this study by using Minitab software. The first is Pearson correlation method. The importance of determining the correlation R is to measure the strength between index properties and engineering properties to compaction. From the data output, if the probability of the variables to maximum dry density and optimum moisture content is less than 0.05, hence the properties are significant in influencing the compaction. After determining the strength of properties, multiple linear regression method was being carried out. This method is to produce mathematical equation based on correlation values, while only selecting the most significant strength. Lastly, response surface method is used to produce the 3D modeling. This method only allows 2 significant factors that affect compaction. These 2 values are being determined by the correlation R values from the Pearson correlation method. From the result, I can conclude that as bentonite percentage increases, the compaction properties performance are better. Due to this, the hydraulic conductivity will be low and suitable as soil barrier. The first modeling is to predict the maximum dry density. 4 models are developed by multiple linear regression method to measure the strength of each properties to maximum dry density. As we can see, model 4.3.4 have the best strength due to the R values. This shows that energy, liquid limit, and optimum moisture content are significant to influence maximum dry density. Yet, the most two factors that affect maximum dry density can be decided from correlation, which are energy and bentonite. This is because the values are nearest to 1. As for optimum moisture content, 6 predictive models are developed to measure the relationship using multiple linear regression method. Model 4.2.6 has the best relationship with two major correlations, which are energy and maximum dry density. As we all know, dry density's value shall be lower to enhance the linear performance. From the 3D output, we can see that the lowest maximum dry density value could be obtained at compaction effort less than 1000 kN per meter cube, with addition of bentonite around 10 to 15%. Theoretically, high value of optimum moisture content will result in lower maximum dry density. Therefore, the highest prediction of optimum moisture content value can be obtained with energy less than 1000 kN per meter cube. From the 3D models, we can say that the maximum dry density values would be less than 1.75. For validity checking, smoothing exponential method is being carried out. This method includes the error analysis of developed models. From the result, the error of maximum dry densities are less than 1. Meanwhile, for the optimum moisture content, the error analysis is less than 7. In conclusion, all objectives stated earlier has been achieved. This study has obtained the physical and geotechnical properties of soil from previous collection data, developed empirical predictive model based on regression equation, and validate that residual soil is suitable as soil barrier with addition of bentonite. However, there are some limitations for this study. This is because the predictive modeling are restricted to residual soil only. Hence, future research may improve this study by testing different bentonite percentage, different energy compaction, and predicting the values of hydraulic conductivity. That is all from me. Thank you.